Hello to my fearless Team Fliegelschnurz. I am so glad to be coming to you this afternoon. It's a nice, gray, rainy, drizzly Sunday afternoon. Typically, I do not do well with gray, drizzly days, but we were blessed with so much sunshine this summer and this fall that I'm very grateful to the Lord that we have some rain and some cool temperatures. My chickens really don't know quite what to do with all of this strange stuff that's coming out of the sky and sprinkling down on them. So we're going to go ahead and work on section 2.5, 2.6, and 2.7, but this video will just be section 2.5. I'll probably end up with a couple of them so I can go through several exercises for you, and you just heard a text message come in. But I'm not going to bother turning my phone down. First, before we begin, what do you call a person who washes whales? Like perhaps Shamu down at SeaWorld? What would you call the person who washes the whales? Well, he or she would be called a blubber scrubber. I just love this book. It is just absolutely excellent. So, problem solving. Word problem solving, that's what you use algebra for, is to take real-life problems and be able to figure them out. And if that's not something that you particularly enjoy, then you probably don't want a job where you're using applied math. But while you get to have all of the wonderful enjoyment of being with Miss Fliegelschnurz, as you so kindly christened me at our last class, we are going to do some talking about solving real-life problems. So what do you do when you've got a word problem that you are struggling with? Well, let's look at this. We have some very incisive, brilliant teaching right here on page 57 of your text. It says, read the problem. Well, of course you're going to read the problem. But there is a clue, or there's a key to how you read it. You don't want to just read the whole big old mess and then say, I don't have a clue in the world what I'm supposed to do. And the reason that you don't have a clue what you're supposed to be doing is the fact that you're trying to read several different pieces of data at one time. And your mind really is wanting to deal with one piece at a time. Like, first off, what exactly are they asking for? What bits of material have they given you? Have they given you any material that you don't need? How do you want to set up and define your unknown? Sometimes you can define it in more than one way. What way works best for you? Is there a chart that you need to fill out? All of this goes into the planning phase. You've got to come up with a relationship between the different pieces of information that you have in the problem. And I do want to go ahead and begin with example 1, which is on page 58. And we talked about this on Tuesday, but we're going to go ahead and do it again. And we talked about, how much the junior high kids would so not enjoy being in Mr. Pearson's drama class, because this is what the story tells us. The problem says, and you do want to read the whole thing through once first, just so you get a general idea of what the overview is, general overview of it. Each boy in Mr. Pearson's drama class is to be paired with a girl in the class to perform a comedy reading. After each boy is assigned to a particular girl, there are 4 girls left. If there are 26 students in the class, how many girls are there? Now, is it asking for how many boys? No. The question is, I didn't set up my limits here. What do we want to find out? We want to know how many girls there are. Is that what I just said, or did I say boys? Let me look and see. How many girls are there in the class? Oh, and I'm so excited. Only a grown-up can get excited about this, but I had my eyes checked on Friday and ordered new glasses, so hopefully in a week or 10 days I won't be doing so much of this trying to figure out if something's actually visible on the board. I really won't know what to do with myself. Okay, so we've been given information. How many girls are in the class? What do we know? Well, we know that there are 26 students altogether. 26 students. And if there are 26 students, can we come up with a question or with a statement that relates the number of students in the class to this total number? Well, we know that there are girls in the class, and we know that there are boys in the class. Now, we're going to assume that there are not monkeys or armadillos in the class, and that the students in the class is simply the boys and the girls is equal to 26. So if we have the number of boys plus the number of girls, we combine them together. You know, no aliens, no visitors, no moms, no dads, no rabbits, no chickens. Number of boys plus the number of girls is going to have to equal the number of girls plus the number of boys has to equal 26. Now, it also gives us a piece of information here. It says in order to do this comedic reading, they're going to pair boys and girls together. So we're pairing up boys and girls. XY chromosomes, you know, if you don't know about it, your parents can also tell you about XY chromosomes. You have pairs of boys and girls. And when all of the boys have been paired up, there are 4 more girls than there are boys. So you have the same number of girls as you do boys, plus 4 extra girls. So when we did this in class on Tuesday, I said, let's have our variable x be the number of boys. Well, since the question was saying how many girls are there, let's not go in the back door here. Let's just say, let x be the number of girls in the class. So you want to define your variable. You could call this the definition statement. Let x be the number of girls in the class. So, if we're going to have the number of girls plus the number of boys is equal to 26, well, we have 26, and we have x right here is going to be the number of girls. Now we have to come up with a descriptive name or a descriptive statement using x that we use for the number of boys in the class. Well, if this is how many girls there are, and there are 4 more girls than there are boys, and we're starting with girls, then if we say that x minus 4, x minus 4, that would have to be the number of boys. And do you see how we came up with this? This is the number of girls. Take 4 of those away. Cover that up right there. Chick-fil-A, go Chick-fil-A. Take 4 away, and the number of boys is the same as you have how many boys there are. So, this is why they chose to have x minus 4 be the number of boys, x be the number of girls. So, we now have the quantity x minus 4 plus x is equal to 26. This is a statement that we are going to solve. X plus x, 2x minus 4 plus 4 is equal to 26 plus 4. We are in Algebra 2. I combined the x's, simply remove the parentheses because we were not distributing anything. So we have 1x, 2x, minus 4. We want to have only x's on the left side of the equation. So we have minus 4 plus 4 is equal to 26. Because we added a 4 to the left side of the equation, we also added to the right side. And we now have 2x is equal to 30. divide both sides by 2, and you have x. What did we say x is? Let x equal the number of girls. So there are 15 girls in the class. What are we being asked to find? We're only being asked to find the number of girls in the class. Now, let's just go ahead and finish the rest of the implied problem here. Like, if there are 15 girls, how many boys are there? Well, 15 minus 4 is going to give us 11 boys, right? Is this a true, did we solve our problem correctly? Well, yes, we did, because we were given information in the problem that there were 26 students in the class to begin with. 11 boys plus 15 girls gives us a total of 26 students in that class. And that is the answer that's the conclusion of our first example problem. How many girls are in the class?